Hey everyone, welcome back to the Viking Initiative for Building Excellence. This video is going to be about science, and it's the last lesson of the ACT course. So, as usual, let's go over the structure and the timing of the section. So, the first thing is for paper ACT, the structure of the test is that it's 40 questions in 35 minutes, which means you have under 1 minute per question, and you want to try and finish this in 32 minutes, giving yourself 3 minutes to review. For the digital ACT, remember science is optional, so only take it if you feel you'll have a good shot at it. I recommend anyone who's taken like an honors science course at her school or an AP science course to take it because it's really just data analysis, data reading. It's just you have to understand like graphs and tables and be able to take make conclusions based on them. So for this, it's 40 questions in 40 minutes. It's exactly 1 minute per question. So try and finish in 37 minutes, again, giving yourself 3 minutes to review. So for the question types, there are three main question types as usual. The first one is interpretation of data, which is 40 to 50%, the largest section. It's about identifying trends, patterns, and relationships, performing basic calculations and unit conversions, and selecting relevant information from visuals. So this is probably the easiest type of science question that you can find. It's just looking at a graph and making simple conclusions from it. Then you have scientific investigation, which is 20 to 30%, which is understanding experimental design and procedures, identifying variables such as independent, dependent, and control variables, and also recognizing limitations and sources of error. So this is basically if you've done a lab in any like physics, chemistry, or biology class, you should know what an independent or dependent variable is, controlled variables, and you should know, what are some of the limitations of a particular experiment given the method. So like systematic errors, random errors, you got to be able to find all of that based on the method that the ACT gives you as context. Lastly, probably the hardest type of question, evaluation of models, inferences, and experimental results. For me, this was the hardest type, especially the first point, comparing and contrasting different scientific explanations or models. Basically, what will happen is you have like conflicting viewpoints. So you have like two scientists who'd have written paragraphs about the same topic, and you have to figure out like basically what they'd agree on and what they disagree on. And it's really unclear. So you have to pick out every single thing they say, make a list of it, and then compare it. The next thing is drawing conclusions from given evidence. Again, this is not too difficult. Um, Given like data, you need to be able to make a conclusion out of it. And then determining which hypothesis or model is best supported. Um, this is again part of like your lab sort of structure. You need to understand, does the data support your hypothesis, does it go against your hypothesis, etc. So it's going to be the same method to study for science as we've done all throughout. You do a practice test and you should be able to find out what you're good at and what you need to improve. So you want to put it in these four buckets. First is what you can do intuitively, graph reading, taking data, etc. Yeah, what you can do consistently but with some thought, that should be your second bracket. um, what you get wrong sometimes, that's your third bracket, and then what you get wrong consistently, that's your fourth bracket. For me, science was like the easiest section since I started. So yeah, if you're struggling with science, I recommend um, like just practicing, because I think it's the easiest one to get better at very quickly. So for this, D and C are top priorities. So you want to find review materials for question types in these categories. Don't put time pressure for these. You want to understand the material first. So it's unlike reading, where you want to put time pressure from the start. Even though it's like the same time per question, science is much easier to do quicker. So yeah, don't put time pressure. Just understand the concepts first. Don't waste your time by practicing concepts in bucket A. And when you see yourself improving, topics considered in DNC, start practicing under time conditions, and add B into this practice. Okay, so for the timing method, this is what I used. So it's under 1 minute per question, so expect to be done in about 32 minutes for the paper, which gives you about, so you have 35 minutes total, and this gives you 3 minutes to spare in the 35 minutes. So you want to try not to skip as many questions because, like reading, a lot of them ask questions building off of each other. So you don't want to miss vital information or have to go back and read the context again to be able to answer that particular question. And then the last thing, take your time reading graphs and tables. There's always small hints in representations of data. So like whenever they give you a graph or a table, it'll always be useful. Don't ever neglect like reading those graphs and tables. Then for digital, B and C still apply, but you want to try and finish in about 37 minutes, which gives you about under 1 minute per question. Um, but you have 3 minutes to review. Science is not as difficult as reading in terms of timing, so having under 1 minute per question is not as much of an issue. Yeah, so for the ACT science tips, yeah, any basic high school science class would have prepared you for question types 1 and 2. Remember, this was everything but like the critical thinking side of it, basically being able to read data and being able to make conclusions from it. So yeah, while approaching type 3, the hardest type of questions to answer are research summaries and conflicting viewpoints. So yeah, so for research summaries, you have to evaluate experiment methods. So basically, like the processes in which they're collecting data. So you want to focus on finding the experiment with the least systematic error. Systematic error just means error that affects every single data point. So like every single time you try and collect data, you'll have this error. So you want to try and minimize that, obviously. So for conflicting viewpoints, you want to read the first description, and then the second one will likely build off of like what the first states. You want to find the differences in opinion and then answer the questions accordingly. So let's do some practice now. So take about like 10 seconds to try and understand this question. Okay, so let's answer it now. So question 3, based on the results of experiment 1, which of the following graphs best show the relationship between the temperature and the distance of the ring from the HCl swab? So looking at the data table here, um, you just have to plot the data and recognize um, like sort of like the trend that the data is giving. So first look at like the x and y axes of the possible graphs. They're all the same, so we don't have to worry about that. So then now we just look at both data. So we have temperature data here, and then we have um, distance data here. So 20, 4.0, 30, 4.1, 40, 4.1, and 50, 4.0. When we look at this, it's kind of, there's not really like a association. The data points stay relatively similar. Like see with 20 and 50, the data points are still at 4.0. So like it's not like moving as much. That means D is the answer because like it doesn't change even when temperature increases, like there's no real association, so it just stays the same. Now let's try another practice question. Okay, so for this one, the question is a student stored 100 peony seeds at a constant temperature for 10 weeks. The student then divided the seeds into 4 sets and maintained them as described in study 2. The results were as followed. So 13, 18, 23, and 28, we see 1630. So these seeds most likely had a storage temperature of this. So when we look at this, there are three variables, right? So we just need to understand like what the table is showing. So in this situation, um, we're trying to find the storage temperature which matches like this particular data, right? So the number of seeds that germinated are 163 and 0. Um, what is most likely um, for 1630 for 13, 18, 23, and 28? So let's look at 0 degrees Celsius. Here we have 15, 24, 21, and 1 respectively for 13, 18, 23, and 28. So 15 and 1, 24 and 6, 21 and 3, 1 and 0, it doesn't really go. Same for 5, it's not really that much of an association. When we look at 15 and 20, they're all 0. Again, not much of an association. But when we look at 10, we have 0 and 1, 6 and 6, 4 and 3, and 0 and 0. So this kind of goes with the data that's shown in this table. So we can sort of like make an estimate that this probably had a storage temperature of about 10 degrees Celsius. So the answer is C. Okay, guys, so that's the end of the ACT course. Yeah, if you have any questions, join the ACT group chat and ask your tutors. You can join on the vikinginitiative.com and look for more AP, IB, SAT, or ACT resources there. So yeah, check out our website and thank you.